Hello, everyone. Welcome to Session 4, Portfolio Analysis with RETScreen Expert at the RETScreen World Conference. Tracking energy consumption, GHG emissions, and various renewable energy and energy efficiency projects across a portfolio of facilities and mobile assets can be challenging. Enter RETScreen's portfolio analysis capabilities to make this process easier. Farah Sharif starts us off with a discussion of Canadian government-wide greenhouse gas reporting with RETScreen. As you can imagine, the Department of National Defense has a very large portfolio. Matt C. Striegler is here to talk about just that, energy management for a very large portfolio of facilities with RETScreen. In closing, Nicky Arthur with LUSH provides a private sector showcase of a new portfolio in RETScreen. Let's now turn to Farah for Canada Government GHG reporting with RETScreen.
In this session, I will present RETScreen portfolio analysis using the Canadian government-wide greenhouse gas reporting portfolio. I will show you the main features available and describe how key users like the Department of National Defense, York University, and Oxford Properties are using the software to track their energy consumption, greenhouse gas emissions, water consumption, and waste production, as well as perform energy management for their whole portfolio. So here we will look at my portfolio, the portfolio analysis. So I'll go first to the portfolio worksheet. So I've opened the portfolio that we've built for the Government of Canada. So in this portfolio, there are about almost 3,000 facilities and files included into this portfolio. So we have files for real property, offices, and recreational facilities, etc. But we also have files for fleet. So let's have a look at the file format. So now we're looking at a portfolio. So it's a RET-P file. The portfolio does a link to multiple RET-X files. Every RET-X file contains the data for either a single facility, a group of facility, such as a campus, a single vehicle, or a group of vehicles, so a fleet. And so the data is collected and stored into the RET-X files, and the data is then consolidated into the RET-P file. And this is where we can see results at the portfolio level. So as you can see here, we have multiple columns describing the portfolio. So we can have here a unique ID, the facility name, a description, facility size, etc. You can also create your own user-defined field. So in this case, we've created a field showing the number of buildings in each facilities, in each file. Then you can do some groups. So in this case, we've grouped our files per department. So you can see the list over here on the left. You could also create some subgroups. So here is an example where we've created a group for a specific province. You can also note that we are tracking the greenhouse gas emissions for air travel. So all the air travel done by the federal employees is tracked into this portfolio. So now let's go and look at some results into the dashboard worksheet. So the first graph I want to show you is a graph showing greenhouse gas emissions for real property and fleet. So for the whole portfolio, portfolio of the Government of Canada. So here in green, we see the greenhouse gas emissions for transportation, and in blue, we see the greenhouse gas emissions for real property. Our baseline year is 2005-06, and we've added a blue line here to show the 2005-06 baseline. We've also added data for 2019-20 and 2020-21 in this graph. The green bar shows the 2025 target, which is to reduce the greenhouse gas emissions by 40%. And the dotted line is the 2050 target, which is to reduce greenhouse gas emissions by 90%. So as you can see here, we've reduced our emissions by 40.1%. So we've already met our 2025 target. And down below here, we have some interesting data that helps us populate this graph. The next graph I want to show you is a comparison graph. So here we're comparing the greenhouse gas emission for the baseline year in gray and with the actual year, which is 2020, 2021 in this case, for every department. So this helps us see the progress per department, but you could group it as you wish. So it could be by province, by facility type, etc. And here we've grouped all the smaller departments together into one bar. Then let's have a look at the next graph, which shows the greenhouse gas emissions per province. So in this bar, every color represents the emissions for every Canadian province. So we can see the evolution over time, and we see what is different in this graph is the shadow area. So the shadow area shows what would have been the emission if the grid had not gone cleaner into all the provinces. So in Canada, there has been some great efforts since 2005-06 to reduce the greenhouse gas emissions of the grid into all the provinces. So for example, in Ontario, the coal plants were closed and replaced by natural gas plants to produce electricity. So if no changes had been done to the grid, we would have emitted more than 1,200 kilotons of CO2. So this portion shows the impact of the grid getting cleaner. Now let's zoom in a little bit. Let's have a look at Natural Resources Canada portfolio. So here, this Natural Resources Canada is the department we work with. It's a department that is developing the RETScreen software. So here we're seeing a graph showing the emissions for all the years since 2005-06, and it's split by fuel type. So in blue, we have the district energy, district cooling, district heating. In green, we have stationary fuel, natural gas, propane, diesel, etc. And in purple, we show electricity. So we see that there is a very nice reduction in greenhouse gas emissions over time. But what we also see is that there are some years, such as 2010 and 2011 and 2018, 2019, where there is an increase in greenhouse gas emissions. So we want to understand what happened there. So let's focus, for example, on 2018-19. What happened that year? When we look at this graph, it's really hard to tell why the emissions are higher. It could be a malfunction in an equipment. It could be a door or several doors opened for long periods of time. It could be the weather. So maybe the winter was much colder in 2018-19 compared to the previous year. It could also be in an error in data collection. So when we look at this, it's hard to get the answer. So we'll continue looking at some results, and then I'll show you how we can get an answer to that. The next graph I want to show you is a ranking graph. So this graph shows the top 10 GHG emitters at Natural Resources Canada. So we see that the Bell's Corners complex is the greatest emitter in our portfolio. It represents 17.1% of the greenhouse gas emissions in the portfolio. What we also see is that the top 10 facilities represent 86.7% of the emissions in this portfolio. And there are 28 facilities in our portfolio. So this helps us decide on which facility we should focus. So we should first focus on the Bells Corners complex because it is the top emitter. And also focus on the top 10 since it represents such a big percentage of the portfolio emissions. So we can prioritize where we take our actions first. But you might think, well, the Bells Corners complex, maybe it has a very large facility area, and maybe that's why it emits a lot. So let's look at a different graph. Let's look at a graph in terms of energy use intensity, so in gigajoules per square meters. So we see here that the top facility is the Inuvik Satellite Station facility, and so this facility is the one that has the highest energy use intensity. But we also see that the Bells Corners complex is still in the top. So we should focus on these facilities as well in order to meet our targets. We also see on this graph a red vertical line. So this line shows the benchmark, which is in this case the weighted average for all the facilities in the NRCan portfolio. So we see that there are 8 facilities that are above the weighted average. So this could also help us target where we should start our implementing energy efficiency measures. You could enter any value as you want for this benchmark. So, for example, if your portfolio is made of office facilities, so you could use the national benchmark for office facilities and enter this here and make it a target. Now let's continue to zoom in. Let's have a look at a group of facilities. So here I'm looking at 10 facilities in the NRCan portfolio. And what we did here, we did some regression analysis. So we calculated some equation to predict the energy consumption for all the fuel used in these 10 facilities, electricity, natural gas, etc. And we used the factor of influence, in this case is heating degree days and cooling degree days, in order to calculate this prediction. So the blue bar is the predicted energy consumption for the 10 facilities. The green bar is the actual fuel consumption. And the purple bar is the difference between the prediction and the actual fuel consumption. So and we call this the normalized savings. So when we look at the blue bar over time, it shows what would have been the energy consumption for these 10 facilities if no measures had been made into the facility. And it corrects for the weather. And the green bar shows the actual energy consumption. So let's have a look at 2018-19. So as we thought, the green bar, the actual consumption, is higher than the actual consumption for the previous year. But when we look at the blue bar, the prediction, we see that it's also higher. So we can say when we look at this graph that the winter must have been colder, or the summer must have been warmer, or both, in 2018-19 compared to 2017-19. And when we look at the purple bar, the normalized savings, we see that in 2018-19 we have 28.7% normalized savings, and in 2017-18 we have 27.7% saving. So even though we consumed more energy in 2018-19, we did better than the previous year. So now we have our answers. So RETScreen allows us, really help us to find these type of answer, and it's really useful and fun to work with. So now let's have a look at the custom dashboard. Here in this section, you can create some very nice reports. So here I've dragged and dropped the different graphs that I've prepared in the dashboard section. So graphs, tables, different types of images, text. So you can really customize the report that you prepare for yourself, for your partners, and for your colleagues, and then share this report in a PDF, for example. You could also show this report, this custom dashboard in full screen for a kiosk, for example. It could be in the lobby of your main facility where you show live the main results and how you're meeting your target in your facilities. So now you must wonder, how do you bring in all this data into the software? So we were looking at almost 3,000 files. There are multiple data every month, multiple meters to bring data into the software. So this can be scary. But we have a very nice feature which is called RETScreen Connect. And this feature allows you to create automatically all your files and to upload your data into the software. And it also helps you update your data on a regular basis. So this feature creates a mapping file that does the link between your data file and your data table into RETScreen. And then you can just use that feature on a regular basis to upload your data into the software. And we've built many connectors to several platforms. We also have a template, and we can adapt to many, many different formats.
Thank you, Farah. Now over to Mats for energy management for a very large portfolio of facilities.
So, hello everyone. Welcome to this part of the RETScreen conference. Appreciate everybody's attendance. What I'm going to talk about today is managing energy in Canada's largest and most energy-intensive institutional portfolio, which is the National Defence Portfolio Facilities. So we're going to run through four main topics in the presentation. The first being the challenge of onboarding 10,000 some facilities into the RETScreen format, using the RETScreen format to support business decisions and track investments in energy improvements. Now we're looking to have the use of RETScreen required for reporting for an energy performance contracts from the ESCO service companies, and then leveraging RETScreen to do fault detection, to do some continuous commissioning, and doing that through direct cyber connections with RETScreen. So we'll get started. Our first presentation here is onboarding the facilities. So, first of all, the big question is, well, why are we doing it? Well, there's a number of policies that dictate how governments are going to manage their business. So the Pan-Canadian Framework, which is our government's clean framework and plan on clean growth and climate change, set up a Treasury Board Secretariat greening government strategy. They've issued a Government of Canada directive that now requires all departments to put all of their assets into the RETScreen format. This is to support our targets in the Canada Sustainable Development Act, which is the next policy driver, our own national defense 20-year time horizon, strong, secure, engage policy, our 5-year plan, and then those get tailored down to our defense energy environment strategy, and from our DAS, which is our Directorate Architectural Engineering Services, issues directives, and there's a new one now called Green Building Directive. This is what our portfolio looks like across the country. If you look at it on a map, It stretches from coast to coast to coast. We have over 10 million square feet of floor space, 15,600 some works. And those works include civil works like roads, water, storm, sewer pipes, airfield, jetties, ranges, and training areas. 800 parcels of land. Our portfolio is about 2/3 the size of the country of Belgium. There's and all of these assets, there's an incredibly wide scope of them. We have everything. You can see the photos here from research labs. We have our own ship refit facilities, shipbuilding. We have armories that are, national heritage buildings. We have messes, like the picture on the right here, that are modern, older ones. We have, and then, that's some of the photographs, but, a little bit more detail on this is that 10.5 million square meters of space. Of that 10.4 million, 8.3 million consumes some form of energy. And that's 10,600 buildings. And then we also have 10,000 housing buildings, which right now we're not including, but eventually they're going to be worked into it. D&D, we steward and manage facilities that are used to house, build, and repair warships, submarines, military aircraft, tanks, armored personnel carriers, and this is all used to command, train, supply, and house our armed forces. Now, because of the size of our portfolio, we emit 48% of all federal government emissions. We have, that volume of emissions comes from the fact that we have 32 main bases, which are the size of small towns, and they range from 3,000 to 20,000 personnel. So just by the numbers here, some of the energy that we consume from coast to coast to coast, right? And it's delivered to us by electrical grids, by the gas pipelines, but it's also delivered by military aircraft, by steamship, and by ice road. So we have 874,000 megawatt hours of electricity that we use, 5.6 million gigajoules of natural gas, 2.6 million liters of propane. That's a lot of barbecues. 1.3 million liters of light fuel oil. And then we use jet fuel as well in the far north to operate some of our facilities. We do still use some heavy fuel oil, but it's gone. We've reduced that quite a bit. And then we use number one, diesel in some facilities as well. And we also have some clean energy. But if you look at that, that's in kilowatt hours. We have 107,000 kilowatt hours of solar photovoltaics. Compared to the 874,000 megawatts, that's not a lot of clean energy yet, but we're really trying to expand that. We're also purchasing 110,000 megawatt hours of green power through the grids. We also use number two diesel, and we are connected to a lot of steam plants. And all of this energy could go to something like a steel forge, a 3-story network server building, a submarine dry dock, or a massive exhaust fan to empty paint fumes from a hangar that houses a C-17 aircraft, or a kitchen for 450 people to sit down and eat. So what are the biggest challenges? Well, one of the challenges is just the sheer number of the regions, the separate regions, the locations of all the buildings to integrate. That's 10,600 buildings. How did we tackle that? Well, we did it staged. We tackled it by province, by province, by province. That's just the way that we had to do it. And we've been doing it now for about 2.5 years. So how do we deal with the various types of buildings? Well, we worked with RETScreen to develop some new customized archetypes in the RETScreen software format that match our building styles. Something like a hangar for an aircraft, a fire hall for the military, barracks. Our barracks buildings are quite different. Some of our maintenance buildings are quite different. So we put those sorts of custom templates into RETScreen so that it makes it much more functional for us. just the number of contact points and regional and local engagement. You have to contact all these people on these 32 bases that know something, that are going to be able to help us get this information into that RETScreen software. So that took constant communication and a lot of effort from the RETScreen staff. Then we had our own data integrity challenges. Sometimes we didn't know where the data was, where it was housed, whether it was correct. And that just took months of validation and research. And then one of the other challenges is once it's all in there, we have to maintain it. A RETScreen file can quickly become sort of not dated if it's not kept up to date. So we have to have established file management and business rules, who is going to be accountable for them, who's going to maintain the data integrity, create master REDX files with someone that's accountable and control that keeps that REDX file updated and only issues copies for people to work with. And then the other thing is we want to make them as useful as possible. So when you have a REDX file, you start with a base case, but the better the base case is, the more data that's in there that's up to date with the condition and the construction and the updates that were made to that building, the better the feasibility outcomes that you're looking for are going to be. So we're working with other platforms to create some automated protocols to get that data exchange. One of the most important being energy consumption. So this slide here, this demonstrates, what the progress that we've made now. So we're 100% entered into in Ontario, 95% in Quebec, 100% in the Western provinces. In the central, which is the National Capital Region, we've got about 90% of our buildings. Atlantic is 80% complete. So we're getting there. Like we're almost in with all of our files, all of our asset files being entered into RETScreen. So the next topic here is supporting business decisions and tracking investments in energy improvements in a portfolio of this size, and this the unique nature of all the buildings. So the principal challenges, in terms of using RETScreen, and not only that, but promoting and engaging with everybody to demonstrate the usefulness and to start leveraging the power of this software program. So first of all, it was the unique nature of military buildings. The biggest issue we had was that early on, RETScreen had a lot of templates in it, but we also have a lot of more unique buildings. So we've developed, I think we're up to about 18 archetypes now. So there are 18 templates that are matched closely to the more military style of building. One of the other challenges we had is a lot of our engineers and facility personnel had this sort of perception of RETScreen. It was a legacy perception from 10, 15 years ago, when there were some issues concerning the power of RETScreen, how successful it was, and how much more that you can do with it. There wasn't a lot of awareness of how it's developed and evolved over time to be a much more powerful and insightful tool that comes out with incredibly close business cases in comparison to other software and programs to make those business decisions and compare the outcomes of various forms of improvements in facilities. So the way that we overcame that is we had a whole, I think we're up to about 4 awareness sessions now. We've been promoting it through through newsletters, through internal communications, but we've also invited we just keep inviting staff and inviting senior people to show them the product, to show them the evolution and development of the software program, and to show them how easy it is to do these three forms of feasibility analysis and what that does for them. And there was also this perception that there's a lot of work to create that sufficient base case in a REDX file. So the way that we tackle that again is through those custom military templates. So they can just select a template. For instance, if they're doing a drill hall and they want to upgrade a drill hall, well, there's one of D&D drill halls which are sort of templated across the country. They just select one of those. There's only a few items to change or modify, and you have very close business outcomes. And then also working with other platforms like meter company cloud platforms or smart building systems to import energy consumption data very easily into the base case of the building file, which is one of the most important pieces of data that you need. And then there's this perception of weakness because RETScreen just focuses on monthly demand profiles. So in order to respond to that, there's now this tool in RETScreen to integrate hourly demand consumption profiles into RETScreen if the engineer wants to insist on that. And there's a lot of debate around those. But if they want to insist on it, there's a tool, you can integrate hourly demand now. And then there's this perception of weakness in the costing outcome. And the way that we did that is just through that awareness and training and how much you can how much data that you can enter into the RETScreen feasibility tools and the breadth and depth of the information possible when you go down to a level 3 analysis. And then just the ongoing training. So we're offering training, we're advertising training. So a lot of our people have taken up the training and they're now seeing we're now seeing the results. So what are the results? What are the successes? Well, it's being used in several cases by engineering staff, by energy managers, by project directors. Our procurement authority is taking the training, and they're looking at using it for RETScreen for both minor and major capital projects. So, and our engineering cell, National Engineering Cell, is recommending that RETScreen be used in the regions and locations for any projects that are less than 5 million in value. That's not to say it couldn't be used for more, but there's a lot of consulting firms that support D&D in those bigger projects. So that's another step forward. So the next topic. So this is one that's a bit more challenging for us, and that's where we'd like to see the power of RETScreen used to leverage energy performance contracts and target and understand better the results and outcomes of the things that are installed under these contracts into the buildings. So what are the challenges with that? Well, first of all, there's contractual issues. These are performance contracts. So the energy service company, most of them have developed either their own, some use RETScreen, but a lot of them have developed their own proprietary tools that they develop themselves, or they use some other form of software to do their own modeling work. So what we're saying to them is that they can go ahead and continue to do that. We just want to see reporting to us done in a RETScreen format, so that there's an understandable language for both parties to look at how the forecast savings and reductions of consumption are achieved when they install all the energy consumption measures. So the way that we're doing that is we're engaging with the ESCOs on developing the feasibility studies, and we're recommending training and awareness for their ESCO staff, and we're tying it into the International Protocol for Measurement and Verification. This is something that's published. It's on the web, and it's used by most energy service companies. And RETScreen ties in very nicely with that protocol. So, and it also ties in very nicely with doing the option D modeling in that protocol. So that is one of the ways that we are already insisting on that in our contracts, that all the energy service contractors follow that protocol. It's an international recognized standard. So this makes it easier for everybody to understand. And then the other thing is that having the basic REDX files ready for use by the ESCO with as much information as possible will help the integration. And then there's the measurement and verification plan. So for every major energy performance contract, there's a measurement and verification plan that has to be submitted with that. So one of the powers of RETScreen is the ability to do the statistical analysis on measurement and verification. And that's where we see one of the greatest benefits, because if there's any non-routine events that might affect energy consumption measures, you can dive into RETScreen and use that statistical analysis to go back in history and look at what was it that affected the consumption of energy, whether it was more or less consumption than what the forecast was. And then you're both talking and you're both using an agreed upon language to do that. The reason that we like that is that it's not this black box that you don't have access to, and you don't have access to the formulas and the background in how those calculations were made. If both parties use a standardized format like this, I think it's going to really reduce the amount of work that's required and the amount of input for successful measurement and verification. And again, you know, the last point was tracking these operational and external impacts to energy efficiency improvements. This is a real challenge for us at National Defense. We're seriously under-resourced for capacity in all our locations. And most of the time, the facility staff are not aware of operational or external impacts created by the users that would impact energy consumption. That's one of the biggest issues that we have, is that these things happen, no one's told about them, there's a difference in consumption, and it's difficult to go back in time. What RETScreen does is it allows you to do that through this regression analysis. Now, this is, you know, the success in terms of using energy performance contracts and measurement for data. This is our success over the last, since 2005 up to 2018. It's a bit dated. This is something that I did in a previous position a couple of years ago. But what you can see here, these two lines, the orange line is our portfolio growth, which, you know, it's gone up from 7.6 million to 8.2 million of heated or conditioned space. And then the green line is the consumption of energy. So we've been successful, despite growth in the portfolio, in reducing the consumption on a per square meter basis. And that's kept our consumption in check. It hasn't, you know, overall from the portfolio, our consumption hasn't decreased, but it would have increased dramatically because the size of our portfolio has increased. Some of the other things that we're doing to get data in, and we're doing aerial imaging, which is the next slide. So what you can see here is some aerial thermographic imaging that we're doing. We're flying drones over the bases to find out where all the losses are coming from in our underground heating pipes. And when we get the data on the amount of energy lost there, we're doing this through some pretty intense algorithm calculations with our aerospace team over at National Research Council. We're calculating the energy loss, and that's going to go into these RETScreen feasibility studies. And with that kind of data, it's able to give us some empirical quantification of energy loss for the business cases. What you can see here is it's a parking lot. You can see a couple of vehicles that were just turned off with some bright orange below them, and then a building in the background on the in the upper portion of the photo here. And then you see this underground heating pipe that's about 6 to 7 feet below ground. You can see the amount of energy that we're losing in those pipes. And the data that from there, this is part of the data, also part of the data. These are heating plants It's a bubble chart. The size of the bubble here is the size of the amount of energy consumed by that plant, and then from left to right is the number of square meters of space heated, and then the horsepower of the plant is the height of the plant. And this gives you an idea of where the biggest plants are and what we have to tackle. So what comes out of this on a portfolio level is we can see, in the regions, just the types of fuel and the fuel level consumption in the different regions. So what you see here is we divide ourselves up by six regions rather than all provinces, because it's a little easier in terms of where our bases are. And you can see our Atlantic region, our Northern region, our Ontario, Pacific, Quebec, Western, and NCR. And this is fuel consumption. So this is fossil fuel consumption in those regions. So you can see where we'd be looking to target some of those regions in reducing the fossil fuel consumption. And this is our emissions trends. So you can see here, Atlantic is one of our biggest emitters. You can see the reduction in the Atlantic. You can see the reduction in the portfolio, and you can see how some regions have reduced, some regions have stayed relatively stable in terms of emissions, but the Western and Atlantic regions have seen significant reductions, and that's from some major steps that we made. And the last topic here is fault detection, continuous commissioning, direct cyber connections with RETScreen. And that's where we want to leverage RETScreen, not to just do business cases like feasibility analysis and portfolio level analysis, but we want to dive deeper into consumption and use it as the one-stop shop to go into some of these things that you do on a per building basis when you're operating the building. And so the principal challenges that we have with that is we're doing a lot of smart building work we've done a pilot on smart building systems to find out what we can do to optimize our operations. And we're also doing work National Research Council to see the types of data and analytics we can get from just studying the meter data on a 15-minute basis. So one of our major issues there was collecting the data and getting the data out to somebody else other than National Defense. There's serious cybersecurity issues with that. Getting data out and getting external links is difficult in this environment where there's these cyber threats from everywhere, and they're trying to find and poke and find vulnerable ways to get into your systems. So if you want, when we want to get data out, it's extremely difficult for us. And then we want to integrate the algorithms and the analytical tools that are being developed and find ways to link them into RETScreen so that there's an easy pathway for everybody to use that same platform. And then there's the cost of that data collection. So the more cyber security elements we put, the more we want to clean, validate, and the more data we want to collect, the greater the cost. So how are we responding to that? So for the smart building work, we're setting up integration of these tools into RETScreen. We've developed our own customized cybersecurity elements that I really can't talk about too much to protect and defend ourselves against those vulnerabilities and threats. We're using the archetypes, and we're working with other platforms. We want to create automated protocols for information exchange. And we're using the RETScreen software. They have these new direct connection tools to create dashboards and create access to different dashboards, and using that connection link to resolve meter networking issues and reduce costs. Why am I so focused on this? So this is a little bit of a demonstration here of what the art of the possible is. So with our meter data, this is just monthly meter data that we're able to get this information from. So what we're able to do, it might be difficult to see on the screen, The bar chart here is for this particular building, how it looks against a Canadian comparison, how it looks in terms of energy consumption against a Canadian comparison, how it looks again for energy consumption for similar buildings on the same base, and then the orange bar is its energy consumption, and then there's the base load and the peak load information for this building against campus. Then there's a heat map. Now this heat map, it's not a map of heat used, it's a map of energy used displayed in this format. So an energy manager can easily see its days of the week, and over months, they can easily see in days of the week if energy consumption was greater on days of the week when there shouldn't be any operations in the buildings, for example, or there's an anomaly, and they can dive in, they can talk to the users and say, what happened? Did you leave the lights on in a large gym all night or something like that? And so for my last slide, I just wanted to sort of explain why I'm such a nerd and we're so passionate about working in this field. And that's this is a slide. It's a bit of a depressing slide from NASA. This is over the last 400,000 years, the amount of carbon in the atmosphere, which you can see by this chart has sort of gone up and down, up and down, up and down, but has typically stayed below 400 parts per mil. Typically stayed between 300 and 320 parts per million on the high side, and we're now well over 360 parts per million, and we're close to 400. And from what I understand, recently we've gone over that 400 parts per million. When you look at this chart and you see that this is the 1950 level, and just before that is the advent of the industrial age. I don't know. You can't tell me that increasing carbon in the atmosphere is not having a significant impact. And that's the way I wanted to end the presentation. Thanks, everybody.
Thank you, Mats. Closing us out, Nicky will go over LUSH's showcase of a new portfolio with RETScreen.
Hi. So I'm here to talk about LUSH and RETScreen in the cosmetics sector. So first of all, a quick introduction. My name is Nicky Arthur. I'm the energy manager at LUSH in North America. I'm speaking today from the traditional, ancestral and unceded occupied territories of the Musqueam, the Squamish and the Tsleil-Waututh nations, also known as Vancouver. So my role at LUSH is I'm part of the regeneration and sustainability team in North America. And I'm based out of our manufacturing facilities in Vancouver. I'm going to talk today a little bit about the why and the how that we're making use of the RETScreen software at LUSH. So I'm going to start with a little bit of scene setting in terms of our North American operations, for those who aren't familiar, and a little look at portfolio and a quick overview of our operations. But before I get to that, firstly, a little bit of background about the brand for those who may not be familiar. Many of you may be familiar with LUSH. Many people I talk to know LUSH as the place to buy bath bombs or a birthday present. LUSH was in fact the inventor of the bath bomb. A lot of people are familiar with the smell of the products as you walk past our shops, which can be quite overwhelming. But one thing you might not know is that one of the reasons that the smell of the products is so overwhelming is that we fiercely believe in reduced or zero packaging. So in fact, 60% of our products don't have any packaging at all. And so that lack of packaging can enables the smell to waft out of the shops and into the high street or into the mall. It's not just bath bombs that we sell that are unpackaged. We also sell naked shampoo bars, massage bars, body scrubs, toothpastes, you name it. There will be a naked cosmetic in a LUSH store. A little bit of background on LUSH and the history. So LUSH was actually established in the UK in 1995. we went on to open our first shop in North America a year later in 1996, which was actually in Vancouver. It's still, the company is still privately owned by the 5 key founders, based in Poole in the UK, with 10% being owned by the employees in an employee benefits trust. We have headquartered in the UK, we have 6 manufacturing facilities and over 900 shops around the world. LUSH, the company is built on 6 principal values. So these are using the best fresh ingredients that we can source, being handmade. So all our manufacturing facilities employ staff that literally hand make the products. We hand press the bath bombs, we pour and hand make all the massage bars and other naked products. We fiercely fight against animal testing, and we have very strict policies not to buy from or work with companies that carry out or fund or support in any way animal testing. We support ethical buying, so we have a very vertically integrated supply chain and take a lot of care in sourcing our materials. And also all our materials are vegetarian, and nearly all our products now are vegan. I think the only product left which is not vegan is honey in some of our products. So the guiding principle of LUSH really is to leave the world lusher than we found it. And that principle overarches everything that we do. So LUSH North America is based or centered around our manufacturing facilities in Canada, which are in Vancouver and also in Toronto. These 2 facilities supply and support 260 shops across the USA and Canada. Our 2 manufacturing hubs are around 250,000 square feet at each location. So in the east, we've got 2 manufacturing buildings and East Mall Distribution Centre. And then in Vancouver, again, 3 factories and distribution centre, a wood shop and the gifts department. So how does that fit in with our goals and strategies? Our regeneration and sustainability team really focuses on our climate plan for climate, our to-do list for climate and nature. So this focuses on 5 key pillars. The pillar that RETScreen really ties into, where I'm going to focus today, is the second pillar, which is to use 100% renewable power everywhere. And so really there's 3 parts to that. To reduce our energy waste and improve efficiency. So really to look at matching the need with the supply and not wasting anything where we can. Then replacing all our use of fossil gas with electricity. So to electrify all of the equipment through all our operations. And then to take that residual electricity that we're using and make sure that as much as possible is supplied by renewable power, with a goal to have 100% renewable power everywhere by 2030. So we've also committed as an organisation in North America to the Science-Based Targets Initiative. So this means that we've set ambitious emissions goals to ensure that we're doing our bit to keep global temperature rise to less than 1.5 degrees centigrade by 2030. So we've got pretty tight commitments around dramatically reducing our scope 2, which is our operational electricity emissions, and then also our scope 3, our value chain emissions, which includes our supply chain, our raw materials, our freight and distribution. So where does RETScreen fit into all of this? Basically, we need an effective tool to help us track our energy and emissions across our portfolio. So to let us see where we're on track with our emissions, let us measure the impact of our projects, and really be able to benchmark ourselves through time and across the organisation. So our base tracking situation currently is using the Energy Star Portfolio Manager tool, which is a free US software. And we really just use that as a whole database. We have a third-party billing company which manages our utility accounts for the 260 shops plus all our manufacturing facilities. And they harvest the data from all the utility bills that come through. And as well as harvesting the billing data, they harvest our kilowatt hour and gigajoule consumption data, which is then entered to Energy Star. So the opportunity for RETScreen really came about from the limited functionality of Energy Star Portfolio Manager. So we found it's great as a database. It works well for our third party in terms of utility upload, but really it doesn't provide a lot more than that. So the visuals element was lacking, and we just needed a more detailed tool for our analytics and our benchmarking. So RETScreen was really identified to be that tool. It was very straightforward to upload the data. It provides some good visuals in terms of graphs and charts that are already very straightforward to pull off the software, and will enable us to do some measurement and verification from projects. So at the current time, we have 6 properties in RETScreen. We've just focused on our manufacturing facilities for now. So we've incorporated the 3 Toronto manufacturing facilities and then 3 of our Vancouver facilities. We may import our retail stores at a later time, but for the minute we're just focused on manufacturing, which is actually the bulk of our emissions and our energy use. So for the rest of the presentation, I just thought I'd give an overview of some of the charts and the features that I found most useful in the RETScreen software. So first of all, benchmarking, which is a sort of #1 tool for any energy manager. And RETScreen really enables us to compare our buildings with each other through a period of time. You can see on the charts here. Just a note, our financial year runs from the 1st of July to the 30th of June, which is why the columns are shown as split years. So this chart shows our use of fuel over time, and then also our total fuel cost, which is interesting and helps us to predict for coming years in terms of cost and consumption. I thought it was interesting that this year, although our fuel consumption actually went up in FY22, the cost remained pretty static. And that's really a reflection of the cost of electricity in BC, where a lot of our manufacturing is having stayed very static over the last year. So despite the energy crisis that's really kicked off in the rest of Europe and has had a huge impact on our other operations, so far in North America, we've been relatively shielded. We've been able to compare the 2, we call it ballistic, so it's actually where we manufacture our bath bombs. We have a dedicated production factory for on each coast, so one in Toronto and one in Vancouver, the ballistics facility. And it's been interesting we're always looking at trying to improve our operations and comparing what we're doing on one coast with the other to really look at quality control, production levels, and just trying to optimize our operations. So interesting to compare the energy use at both facilities as well. Really the electricity consumption in the East Coast was much higher than it was in Vancouver, but actually Vancouver uses more gas. So it evens out in the total fuel, and it enables us to do a bit of modeling around electrification and how that's going to impact our fuel consumption in the different facilities. So this is just looking at on a specific building by building level, and we're able to look over time at savings or increased use based on a weather normalized data set. So this can be one, which is our main manufacturing and office facility in Vancouver. And this enables us to look at the impact of some of the projects. So in 2019, we actually installed a building automation system in Vancouver, and you can see where the savings kick in at sort of 2018, 2019. Then obviously 2020, still seeing savings from the building automation system, but also that's when COVID really kicked in, March 2020. Don't think anybody's forgotten that. So we see more savings in energy And this is just a really powerful tool because we can look in building by building and see effects of projects, and also where maybe the project hasn't had the desired effect. The QSum tool, which is also super powerful and really enables a weather normalized look across a building or a portfolio through time. You can see here the baseline year in 2019, and then the impact of the COVID shutdown, where we actually had to shut down our operations for 3 months. So one of our goals I mentioned earlier is to be fossil fuel free by 2030. So something that we've been able to look at through RETScreen is how we're going to model that out and how we'll be able to achieve that. So this is our fossil free use over the past 5 years. And as you can see, with our goal of 0 by 2030, we've got quite a long way to go. And we're just in the planning stages now of really digging into how we're going to electrify our buildings on both coasts, and then hopefully being able to model that out. One of the other goals we've got through the science-based targets initiatives is to reduce our emissions by 75% again by 2030. So the top graph here shows the total emissions from fuel, so that's really fossil gas. And then the lower graph shows Toronto and Vancouver, just electricity emissions. So if you look at the scale, the bottom graph, the electricity emissions are tiny compared with the gas emissions. So again, through electrification of our equipment, we should be able to achieve this goal. That's really the key part. And then also in the electricity graph at the bottom, you can really see the difference between the emissions grid related to the grid in BC, where 95% of the electricity is from hydropower, so has a super low emissions, which are the Vancouver facilities are the light blue, the little slither at the top, and the small purple slither. And then the larger pieces of the bar are the Toronto buildings, where we have a higher, the grid just inherently has a higher carbon footprint. So really looking at how we can optimize that. Another useful feature in RETScreen that we've been able to make use for is the event log. So using RETScreen to catalog projects as they take place. So building automation system, where we've removed our steam boiler, lighting projects, anything like that enables us to save all those and catalog all the projects in one place. And then we can use the QSum feature or the other weather normalized features to look at savings from those projects. So what are the next steps for LUSH in terms of how we're using the RETScreen software? Really, we're hoping to get some more out of RETScreen. It's a really powerful software tool, and we probably could definitely make more use of some of the features. So we're hoping to really dial into some of the measurement and verification, the M&V features in RETScreen. Working to automate that portfolio manager upload every month. So we've had a few challenges with our third-party billing company, but we seem to be on track with that now. So we're hoping to get that automated and possibly adding some new sites. So maybe start including some of our retail sites, and we'll do a pilot with probably 10 of those in the next year, just to see what value that can add. And then also sharing some of the information. So some of the charts in RETScreen, starting to work out which are some really useful charts that we can share with the staff in our operations, because really we want them to be invested in our goals and helping us achieve our goals and objectives. So that's everything from me. Just a reminder of our overarching mission to leave the world lusher than we found it, and just inviting any questions. Thank you for listening.
Thank you, Nicky, and all our presenters. This concludes session 4, Portfolio Analysis with RETScreen Expert. Thanks for watching.